is title this Balancing Chemical Reaction Notes. Okay, so we're going to go ahead and go over the first page of this, and then on the back is going to be your homework. And so the reaction or the worksheet that you should see, it's called the Balancing Act. So going over this, we have to understand atoms cannot be created or destroyed during a chemical reaction. Meaning I can't have and start with 5 atoms and end with 6 atoms. Okay, if I start with 5, I end with 5. Okay, and to destroy it means I can't start with 5 and end with 3. I can't just magically disappear atoms. They can't go away. Okay, if I start with them, I have to end with them. Okay, so scientists must know that there must be the same number of atoms on each side of the reaction. And so I have a reaction here. And so I'm going to go ahead and I'm going to show you what I mean by sides. And so I'm going to separate this where the arrow is. Okay, so where you see this arrow, so you're going to see me separate it. Okay, and so you have to understand on the left side, we call these the reactants. And on the right side, and I'm going to go ahead and just make it a different color, these are my products. All right, and so what it's saying is if I start with 5 atoms over here, I have to end with 5 over here. Okay, so where it says scientists know there must be the same number of atoms on each side of the reaction, okay, if I have 10 here, I have to have 10 over here. So to do this, we have to balance the chemical equation by adding coefficients. All right, and so you see these boxes here? These are going to be numbers in front of the element or the compounds. And what we call these numbers are coefficients. All right. And so there's always going to be a number. It's either going to be 1, 2, 3, 4, or potentially it could be 5. All right. But what you cannot do is you cannot add or change subscripts. And subscripts are these numbers down here. Okay, so they're these little numbers here. And even if we don't have a subscript, I can't add a subscript. So I can't say Mg2. Okay, if it's Mg by itself, it's going to stay Mg. Okay, so the subscripts are these little numbers right down here. And if there isn't a number, you just assume that it's 1. And then the coefficients are going to be the numbers we add in front. All right, so the instructions here are 1, 2, 3, and 4. So we're going to start with 1. Determine the number of atoms I have on each side for each element. Okay, and so by looking at this, right now I have 1 magnesium because there's no subscript here. So to assume that I have 1, I have to write at least the element. So I have 1. And let me go ahead and make this black. Okay, so right now I have 1 element because I have 1 magnesium. Now looking at oxygen, I have 2 elements because I have a subscript of 2. So it's telling me I got 2 oxygens. Now looking on the right side, there's no subscript that goes to magnesium. So technically I have 1 magnesium. And oxygen also doesn't have a subscript. So I have 1 oxygen. Okay. So if we look at this, and so we have to assume that my reactants, what's reacting and what's produced, my products, they have to be the same. Well, if we look, magnesium's 1 on the left side, it's 1 on the right side. But oxygen is 2 on the left and 1 on the right. So technically right now it's saying I lost an oxygen. It's not possible. I can't destroy an atom. Okay, so what we have to do is we have to rearrange, okay, how many molecules that we have. And by doing that, we add coefficients. So number 2, it says pick an element that is not equal on both sides of the equation. Okay, so oxygen is the one I'm going to pick because we can see it's not equal. So what we do is we add a coefficient in front. So I'm going to say, well, what can I multiply 1 by that's going to get 2? And well, it's 2. Okay. And so you have to think of this like a math. If we go ahead and put a coefficient in front of something like a simple algebra problem, and so I'm just going to write this so this kind of makes sense for you guys. What a coefficient is, just like this, is it's just telling me to multiply to everything inside. And so it would be 2x plus 2. Okay? Well, that's exactly what these coefficients are doing. And so if we look at it, I have to multiply this 2 to magnesium, and I have to multiply 2 to oxygen. And now you're saying, what are we multiplying by? Well, there's no subscript, so we assume there's 1 for each. So it's going to be 2 times 1. So now I'm going to have 2 magnesiums. Well, you're saying, well, Mr. Sassfi, you're now just unbalancing it. That's fine. Sometimes you have to unbalance to make it balance. But what it does balance, and if you look, is it's going to balance my oxygens. And so I'm going to not have 1 oxygen anymore. I now am going to have 2. So now if we looked, we've gone ahead and balanced the oxygens. We have 2 and 2. Well, some of you are probably thinking, well, Mr. Sassfi, now my magnesiums aren't balanced. That's okay. Well, if you look at it, I now have 1 on the left side and I have 2 on the right. So the object is to get my smaller number to the bigger. So I have to change the 1. And because it's on the left side, I have to add a coefficient in front of the left magnesium. So I'm going to go ahead and put a 2 here. Okay. And so you have to think that there's a coefficient, or not a coefficient, there's a subscript of 1 here because there's no number. So 2 times that 1 is also going to get me 2. And so you balance this, and so you add a coefficient in front of the formula with that element and adjust your count. So just like we did, okay? And you continue adding coefficients to get the same number of atoms on each side. And what we mean by side is on the arrow. So before the arrow is the reactants, after the arrow is the products, okay? And so we have to have it on each side of that arrow. And so I've gone ahead and separated it. Now you can see I now have 2 magnesiums on the left and the right, and I have 2 oxygens and 2 oxygens. Okay, and so what I'm going to go ahead and do is any box that I haven't filled with a coefficient, I'm going to put a 1 in front of it. And so I'm going to go ahead and draw this out for you guys so you guys can understand what's happening. Okay, so we have a magnesium here, and so I'm going to go ahead and draw my magnesiums as red. So I have a red magnesium. I have a red magnesium here. Okay. And I also have another magnesium because it's saying I have 2 magnesiums. So I have 2 separate magnesiums. All right. And so I'm going to make my magnesiums red and my oxygens. Now it says I have 2 oxygens bonded together. So I'm going to go ahead and make my oxygens purple. But notice I'm putting them together. And the reason being is because they're bonded together. Now, this is 1 molecule, and this coefficient is telling me how many molecules I have. Okay, so over here, you can notice these reds are not added, but there's 2 coefficient, so I have 2 separate atoms. So if we look over here, you have MgO. So what that's really saying is I'm going to have a magnesium with an oxygen, so it's going to be a red with a purple, okay, because that's what the compound tells me. But the coefficient's telling me I have 2 of these. So I have 2 of these individual compounds. Okay. And so if you guys can see the elements themselves, I started with 2 separate magnesiums, and I added them with an oxygen. And when they get into close contact, you could see the products. It separated my oxygen molecule, and each magnesium took an oxygen molecule. So if you notice, I have 2 reds and I have 2 reds over here. I have 2 purples and 2 purples. And so what you're doing is you're actually balancing the reaction to have the same amount of atoms you started with to what you ended with. Okay, so let's go ahead and do the next one together. So again, what I'm going to have you guys do is separate at the arrow because you're going to go ahead and put your reactants in your products. All right. So what I want you doing now is go ahead and count up how many calciums and oxygens you have on the left and how many you have on the right. So what I have, and so I'm going to look at calcium first. I have 1 calcium here. Reason being is I don't have a subscript, so you assume there's 1. And then oxygen, it has a subscript of 2, so I have 2 oxygens. Now I had to look to the right of my line. Calcium does not have a subscript after it, so I have 1. And oxygen also has 1 because there's no subscript like it has over here. So this kind of looks like the problem that we just did up top. Well, calcium is all right on the left side and the right side, it equals. But on the right side, for oxygen, I have 1 less oxygen, which I can't have. So the question is what can I multiply this 1 by to get it to 2? Well, that is going to be the answer to your coefficient. And so I'm going to put 2 because 2 times 1 equals 2. And I'm trying to get it to 2 over here. And so if I look, this 2 multiplies to the calcium and it multiplies the oxygen. And so if we look, it's going to change both the numbers of calcium and oxygen. Okay? And so I'm going to have 2 calciums because 2 times the coefficient here, the subscript here, which is 1. And then 2 times oxygen, which also makes it 2. Okay, and so if we look at it, oxygen is now satisfied. So now we have to look at calcium because calcium is no longer balanced. And so because I have 2 calciums on the right, my calciums on the left also have to equal 2. And so what I'm going to do is I'm going to put a number that I can multiply by 1 to get it to the number over here, which is 2. So 1 times 2 equals 2. And so what that is doing is this 2 is going to multiply just to the calcium. All right, and so it's going to change this to 2. And so if we look, we now can stop because everything equals the left side to the right side. I have 2 calciums, 2 calciums. I have 2 oxygens to 2 oxygens. So any box that doesn't have a coefficient, you just add a 1. Okay, so my ratio is going to be 2, 1 to 2. Okay, let's go ahead and look at the next problem. I have nitrogen plus hydrogen equals NH3. And so once again, I'm going to separate my left side to the right side. Okay, and now I'm going to count up how many I have on each side so I can figure out what is not balanced. Okay, so looking at the left side, I have 2 nitrogens. I also have 2 hydrogens due to their subscripts. If I look to the left, now a lot of you would say I have 3 nitrogens because it has a subscript, but it doesn't. I only have 1 nitrogen because there is no subscript next to it. Now, hydrogen has 3. The subscript only goes to the element it's next to. So technically, nitrogen only has a 1 right here because it doesn't have a subscript. So that's the way we have to look at it. Okay, don't think you have 3 nitrogens and 3 hydrogens. That 3 only goes to the hydrogen. Okay, if it was gonna be 3 nitrogens, this is what it would look like. It would look like NH3. Okay, this would mean I have 3 nitrogens and 3 hydrogens. But that's not what I have, so we're going to ignore this. Okay? So understand why I have 1 nitrogen versus 3 hydrogens. So if we look, well, you're looking, well, Mr. Sassby, which one do I start with? Okay, well, pick one. Okay? To me, what number can I multiply 1 by to get it to 2? And then hydrogen, what can I multiply hydrogen by to get it to 3? Well, and you can notice there's no number I can multiply hydrogen by to get it to 3. So the easiest one to start with right now is nitrogen, okay? And so hydrogen, the question would be is what number can both 2 and 3 go into? All right? And so I'm not going to deal with hydrogen now. I think nitrogen's easiest. I can change this to 2. All right? And so my goal is to get this to 2. And how I do that is I'm going to put a 2 coefficient. Reason being is 2 times 1 is 2. But now I have to look at what that coefficient also does to hydrogen. So what's 2 times 3? And so 2 times 3 is going to get me 6. And you're like, oh no, Mr. Sassby, something's wrong here. You're fine, okay? Because what you've done is you've gone ahead and balanced nitrogen, and now you're thinking, well, I've only made the separation between the beginning hydrogen and ending hydrogen bigger. It's okay, okay? Now, what can I multiply 2 by to get it to 6? Well, that answer is going to be the coefficient I put in front of hydrogen. And so 3 times 2 equals 6. And so my new number is going to be 6. And now you can notice, oh, well, Mr. Sassby, now I'm balanced. Well, yeah. I have 2 to the left, 2 to the right for nitrogen. I have 6 and 6. So I've gone ahead and balanced. Now, any coefficient or any molecule that doesn't have a coefficient, add a 1 in front. So I'm going to have 2 nitrogens versus 3 hydrogens to equal 2 NH3s. Okay? So I'm going to go ahead and do one more with you. Then I'm going to let you guys work on the rest on your own. Well, now we have a different compound. It's a little harder to the extent that we now have one more coefficient that we're going to have to worry about. Okay? So we're going to go ahead once again, follow the same rules. I'm going to go ahead and separate the left side, my reactants, versus the right side, my products, where the arrow is. So looking at the left side, you should have 2 coppers, because there's a coefficient of 2 here, or not a coefficient, a subscript of 2 here. You should have 1 oxygen, because it doesn't have a subscript, so we assume it's 1. And then carbon also has 1, because it does not have a subscript with it. So looking at the right side, I have 1 copper because there's no subscript here. And so I have 1. I have 1 carbon, and the reason being is that subscript is next to oxygen. Okay? And if you put 2 carbons, what it would have to be for it to be 2 carbons would be this. Okay? This is when it would give me 2 carbons. All right? But that subscript is not here. It's only behind the oxygen. So understand this is once again not what we're using. So that's again why we have 1 carbon, because we have to assume because there's not a number, there's 1. All right? So now the thing is which one do you want to fix first? Okay? Well, I'm just going to start with the top. Copper has 2 on the left, so what can I multiply 1 on the right to get it to 2? And so my answer is 2, so I'm going to go ahead and put a 2 here. And so what that does is that goes ahead and balances my coppers. Well, now I need to balance my oxygen. Okay? And so I'm going to go ahead and what can I multiply 1 by to get it to 2 on the right? And so I'm also going to put it to 2. But notice this goes to both copper and oxygen. So 2 times 2 is now going to give me 4. And then also 2 times 1 is going to give me 2. Now some of you are thinking, well, Mr. Sassby, we just balanced copper and now you unbalanced it. Well, that's fine. Okay, so what can I go ahead and do is I'm going to go ahead and erase this again. And so what I'm going to do is what can I multiply this copper by? So I'm going to get rid of it. So what can I multiply this original copper by to get it to 4? So I'm going to change the subscript, and originally we put 2. Now I'm going to change it to 4, because 4 times 1 is going to get me the balanced version of 4 coppers over here. Because remember, I had to put a 2 here to balance out my oxygens. Okay, and so I balanced my oxygens. In doing so, I doubled my coppers, so I have to double my coefficient in front of copper. Okay, and so it's going to be 4 here. Now, if you look, it all worked out. So anything that does not have a coefficient in front, I add a 1. And I'm going to balance. So understand that you guys may have to go back and change coefficients to rebalance. Just like we did the copper here. We originally put a 2 and realized it worked originally until we went ahead and balanced the oxygens. Then it unbalanced my copper, so I had to go back and fix it where it needed to be fixed. Okay, so what I want you guys going ahead and doing is I want you to try this next one. Okay, and if you notice, I'm actually going to go ahead and go over this one because there is something tricky about this, but it's not that hard. So if we look at my hydrogens and oxygens, I should have 2 and 2. I should have 2 and 2. And now for the hydrogens and oxygen, hydrogen again, I have 2. But if you guys look at this, I actually have 3 oxygens. Okay, and if you look, it's because I have 1 oxygen here plus 2 here. Okay, so it's 1 plus 2, so I have 3. So what we're going to go ahead and do is we're going to try to go ahead and balance this. And there's multiple ways you can do this, but don't worry, all right? There's always a way. You can just go back and fix it. So what we're going to do is, well, what can both 2 and 3 both go into? And so your answer is 6, but the question to me is it's always easiest when we have a split element to get them to an even number. So what plus 2 and what can I multiply this 1 by to get it plus 2 to get it to an even number? And so I'm going to just start out by putting a 2 coefficient in front. And so what you do is you change your hydrogens and then you change your oxygens. Okay, and so I no longer have 2 and 3 for hydrogen and oxygen. I now have 4 hydrogens because 2 times 2. And I now have 4 oxygens. Reason being is 2 times 1 is 2 plus 2 is 4. Well, notice, what coefficient can I add in front of both of these that can change them both to 4? And so your answer is going to be 2. And so 2 times 2 and 2 times 2 will both equal 4. So if you notice, it's now balanced. So what I'm going to go ahead and do is fill in the rest of my coefficients with a 1. All right. And so this is how it's going to be accurately balanced. And so what I want you guys to do on your own is go ahead and finish the back page. Okay. I am also going to add 1 extra credit point if you can get the challenge problem correct. Okay. We will be grading this in class. For cohort B, it will be on Friday. We're going to be grading this in class. And then for cohort A, we're going to be grading this on Monday in class. So what I want you guys to do is write this on a separate sheet of paper. Okay, if you have problems, email me, and then we can work on it together via Google Meet.